Alright, let's see. This is Professor Reed, so let's see if we can get through this problem. On the practice problems, it says, what is the solution of the system? Use a graph. All that means is where do these two linear equations intersect? So all we have to do is graph them. So we have y equals negative x plus 2. That means it intersects at the y-axis at the point 2. And it has a negative slope, so that means it's going to go this way. Well, this line could be it. This line is negative. It cannot be it because it does not go at the point the y-intercept is negative 2, so it cannot be C. This one has a y-intercept of 2, but it has a positive slope. So it cannot be B. And this one likewise intersects at the point 2, but it has a positive slope as well, so it cannot be D. But we could continue that just to make sure. We check this one, and it has a y-intercept of negative 1, which is here. It has a positive slope of 3, up 1, 2, 3, and over 1. So the slope checks out on both of these and the y-intercept. So your answer on this first one is A. Okay, we have number 2. What is the solution of the system? Use a graph. It's the same idea. Well, let's see. This first one is in y-intercept form, y equals negative 5x minus 2. But this next one, we need to put in slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. So all I need to do is subtract 2 from both sides of this equation. That gives me y equals negative 5x minus 2. I'll just recopy this one. Y equals negative 5x minus 2. Interesting. They're actually the exact same line. Hopefully you noticed that. So they intersect at the y-axis at negative 2, which is here. It's also here. It's also here for one of these lines. Now this one doesn't intersect here, so we can immediately rule that out. This one has a line that has a positive slope and a negative slope, whereas both of these are the same line with a negative slope, so we can rule that out. This one is actually two parallel lines, not the same line, so we can rule that out. So we have choice A. Okay, number 3, what is the solution of the system? Well, we can do this a couple of ways. We could actually just graph these, and that'd be pretty easy. So I'm just going to pull up a different screen. And we had y, oops, we get something I can write with. Y equals x plus 6, and y equals 2x. So we could graph these two lines. The first one, y equals x plus 6, would be a positive slope with a y-intercept here, and it has a slope of 1. So we could do a straight line, and it would look something like this. And go on in both directions, of course. And then we have y equals 2x. So that just simply means it has an intercept of 0, 0, and a slope of 2. And that's going to take us a while to figure out where that's going to intersect. So that's going to be way down here somewhere. So that's not the most practical way in this case to do this. Is not going to be the graph. It's going to take it a long time before they intersect. So we're going to do that a different way. We'll use substitution for this one. This says y equals 2x. So whenever I see y in this other one, I'm going to substitute 2x. So I have 2x equals x plus 6. I just plugged 2x in for y there. I'm going to solve for x, minus x, minus x. And that gives me x equals 6. So x equals 6. And then to get y, I just plug 6 in for x. So I can just do that right here. So in this equation, y equals 2x. I know that x is 6, so I just plug that in for x, and I get y equals 12. So it's the point 6 and 12. In my other one, we might have found that, but it would have been up here somewhere off the graph. Okay, so here we have two more. It wants to know how many solutions. Let's get them both in y equals mx plus b form, then it'll be really easy to compare them. So this first one, x equals negative 4y plus 4. Well, I want it to look like this when I'm done. So I'm going to add 4y to both sides. That'll give me 4y plus x equals 4. These cancel out. I'll subtract x from both sides, and that'll give me 4y equals negative x plus 4, and I want to divide both sides by 4, and that'll leave me with y equals negative 1/4 x plus 1. I'll write that up here. Y equals negative 1/4 x plus 1. Now I'm going to erase that. And now I'm going to work on the other one. This here, 2x plus 8y equals 8. I'll subtract 2x from both sides. That'll leave me with 8y equals negative 2x plus 8. And divide both sides by 8. These cancel out, and I'm left with y equals negative 1/4 x plus 1. Notice that is exactly the same as this, which means on that graph, those lines are right on top of each other, which means they have infinitely many solutions, because every part of each line is a part of the other.